Hi guys, Buildzoid here, and today we're going to be taking a look at the MSI X470 Gaming Pro Carbon PCB. So this is MSI's second to the top motherboard. So they have the gaming M7 above this, and then there's this thing. So before we get into the VRMs, let's go over some of the features that this board has that, will help you out with overclocking. So right here you have four debug LEDs, which basically tell you if you have a problem with the boot device, VGA, so GPU, memory, or CPU. There is no postcode, and there is no speaker integrated onto the motherboard. So that's, this is, as far as I'm concerned, the bare minimum in terms of troubleshooting troubleshooting equipment on a motherboard, like having the four LED indicators. And often enough, this is enough to get you past most issues, but it's not ideal. But it is the bare minimum, and in most cases it'll be enough. But if you're doing some more advanced overclocking, then you really want to postcode, not this, because the postcode will help you can help you troubleshoot specific issues, whereas this will just sort of tell you, well, the RAM's not working. Why isn't it working? I don't bloody know, because with a postcode you can sometimes tell if it's it's the memory controller not liking the settings, or it's the memory stick not liking the settings, or but yeah, this will work. This is fine. Above the memory slots, you can't see them, but there's four LEDs up here, and those will actually indicate which memory slots are working. So if you install if you install two memory sticks, you'll have two LEDs light up based on which two slots they're installed in. You install four, you have four LEDs light up. If you install one, you have one LED light up. So kind of handy. I imagine they should also drop out if one of your memory sticks fails to initialize. Though I've not actually seen that happen, because for me so far with the MSI, with the MSI boards I've used so far, it either boots or it doesn't. I've not had it fail to post memory channels yet. So yeah, but it's still nice that it's there. I'm not sure if it does that. It might, but I've not been able to get it to boot with just one memory stick out of two working. So yeah, that's that. Then down, let's see. Up here, you get a clear Cmos button, so that's nice. And this is the proper place to put a clear Cmos button, on the rear I/O, as far as I'm concerned, because the Gaming Plus has a clear Cmos. It's along the bottom edge. But if you have that in a case, you still need to open the case up, and at that point, it doesn't really matter if you're opening the case up to get at a button or at a jumper. Kind of equivalent, because the main issue there is removing the side panel, not the whole thing you have to do once the side panel is removed. This, on the other hand, does mean that, if you have the board installed, you just press the button while it's powered off, and you can clear the BIOS. So that's nice to have right there. MSI also has this Mdot To Shield. Note how this isn't called a heatsink, because it isn't a heatsink. If it was a heatsink, there wouldn't be a sticker. Well, is it yeah, it's a sticker. I'm pretty sure it's a sticker. Give me a second. Okay, no, it's not a sticker, but it would have surface area, and it doesn't have surface area. This is literally a metal plate the same size and shape as as your M.2 SSD. So if you put this on your M.2 SSD, it makes zero difference to how much surface area the thing has. So yeah, it might protect your M.2 SSD from physical damage, but it will certainly not do anything for its thermals. If I'm not mistaken, last time Gamers Nexus tested these Mdot To Shields, and if anything, they made the thermals worse. The SSD ran hotter. So yeah, that's a total non-feature. Also up here, we have two 8-pin power connectors, because MSI got really confused and misread X470 as X299. And so when they did that, they figured, oh, right, we need to design a motherboard with power connectors that can deliver, 960 watts, because the Skylake X CPUs fit into this socket right here. Yeah, I'm not impressed. The two 8-pins on this motherboard, it shouldn't be there. Now, luckily, for this board, they don't advertise those two 8-pins as actually doing anything. However, for the gaming M7, MSI advertises the extra 8-pin as actually being helpful for overclocking, which is a straight up lie. It doesn't do a damn thing, because your first, like, one of these freaking power connectors is good for 480 watts. Okay, and if you want to stay on the safe side, you're still good for like 300. Okay, like under less than ideal conditions, you're perfectly good for 300 watts on one of those. And your Ryzen 2700X, if you're being stupid, will probably peak around 300 watts on like ambient cooling. If you're on liquid nitrogen, you can significantly exceed that, but you shouldn't use this, like you wouldn't really want to take this motherboard on liquid nitrogen, in my opinion. There are motherboards much better suited to that. The other issue is that if, you know, for some reason, because somebody's going to be like, oh, but it's for future proofing when Ryzen 2 comes out, like Zen 2 comes out, or some, you know, higher core count CPUs for the AM4 socket come out and they pull more power than what we have right now. Well, here's a fun fact, right? If you try to push if you exceed the capabilities of one of these 8 pins, so let's say you start trying to push like 600 watts, the problem won't be how many 8-pin power connectors you have. It'll be this VRM right here. It has no chance at that kind of power output. Okay? No chance whatsoever. So the second 8-pin is a complete waste of money. It shouldn't be there. I would be much more appreciate if this board had a single 8-pin, you know, literally just one 8-pin, and instead of doing this, they took the BIOS chip down here and put it in a socket. Because MSI for the B350 and the X370 motherboards, I did read a lot of posts from people about how MSI's BIOS updates were bricking boards. And because of that, you know, it'd be really nice if the motherboard had some way to recover from a bad BIOS flash, except it doesn't, because the BIOS chip is soldered on. There's one of them. And yeah, well, basically, if this board, if you screw up a BIOS flash on this motherboard, you're going to be sending the entire board to MSI for RMA. Which, if they just put the chip in a socket, right, the BIOS chip in a socket, then if you called MSI RMA with a corrupted BIOS issue, they could just ship you a new BIOS chip. That's good. Or you could also, or the other option is they could have had a spare BIOS chip in the motherboard box as part of the accessories. Like, that would have also been a completely acceptable way of dealing with recovering your BIOS chips, you know? So yeah, this doesn't need to be there, and this should be socketed as far as I'm concerned. Or they could have used like a full dual BIOS implementation, but a dual BIOS implementation, as far as I'm aware, is actually more expensive than to just put the chip in a socket. So yeah, and I have a sneaking suspicion that this 8-pin is more expensive than like putting the BIOS chip, like buying a socketed BIOS chip and then a socket for the BIOS chip. So yeah, I'm like, that is like my main complaint is like, if you brick the BIOS on this motherboard, you're going to be real, like you're sending the whole board away for RMA. So hopefully I don't run into that, because that is like, because I do remember, I have read a lot of people complaining about that being an issue on past MSI motherboards, and it's just like, well, that's kind of unacceptable, you know, especially when your motherboards don't have any way to recover from a bad BIOS flash, because there's no dual BIOS, not even like dodgy dual BIOS like what Gigabyte does with their software implementation. I don't even get why they do that. It's just like, why don't you just use a freaking switch? It'd be so much simpler. Just put a freaking switch for the BIOS chips. No, one BIOS chip, you need more RGBs. Oh, and an extra 8-pin, because, you know, X470 is suddenly turned into X299. Anyway, let's get to the VRM, which is like the one part where I don't have too much to complain about. This right here is the vCore. And this right here is the SoC VRM. Oops, overdrew that. So that's your VSoC. And this may look like a 1, 2. It's supposed to be a 2, 3, 4, 5, 6, 7, 8, 9, 10 phase with a 1, 2 phase over there. In reality, it's a 5+2. Okay, so basically the vCore VRM is split up in blocks like this. And the reasoning for that is that this chip right here is a IR35201, which is a perfectly good high-end voltage controller, but it only supports VR phase counts between sort of 6+2 and 8+0, and anything lower than that. So what MSI is running here is a 5+2 phase. So that's what they're running here. And with the 5+2, now the thing is, they could have actually doubled off of this into an actual tenant phase, but instead of doing that, they use right here, this chip that they have there, that is the actual driver chip, and that is a CHL8510, and that's a really, really like strong single phase driver IC. So basically you have a PWM signal go in, and then it turns on it's capable of controlling one phase of MOSFETs. Interestingly enough, they did actually use the chip that if they wanted to do a 10 phase, the easiest way they could have done it is used a bunch of the chip, like this chip right here that they have, which is an IR3598, which is a dual driver and or doubled driver. So you can do one PWM signal in and two sets of drive signals out. But I assume why they opted for the CHL8510s is that basically it ultimately wouldn't have made that much difference to the VRM's actual thermal performance or efficiency if they went for the 3598s. And it would have, had some improvement for your, like, voltage ripple would be better if you actually had all the phases interleaving. But the 8510, like, it simplifies the design a lot because you can just wire your gates for your MOSFETs in parallel and then hook both of the MOSFETs to one CHL8510. So this simplifies design. It's not, better. But ultimately, I don't really see a huge problem with what they've done here. You basically have a very big 5-phase VRM. So, you have like 5, and then this right here is 4, 3, 2, 1, because these blocks turn on together. And there's one CHL8510 on the front here. The rest of them are on the back of the board for these phases. The SoC VRM has the 3598, and that's running in dual driver mode, so it's not doing doubling. So there's +2, and you get 2 PWM signals going into that chip, and then that chip then controls 2 phases. So that's a real 2-phase right there. Even though you do have just one chip driving both phases, it's real because that chip has 2 sets of drives in it. So yeah, that's the VRM control situation. For the MOSFETs, they went with the exact same ones that they had on the Gaming Plus, and I think they also have these on the Gaming M7. The high side MOSFET is a 4C029N from On Semiconductor. The low side MOSFET is a 4C024N from On Semiconductor. The low side MOSFET is 2.8 milliohms. So that's nice and low. It's not the lowest low side, like not the lowest RDS on you could get by far, but it's a lot better than a lot of other motherboards we've looked at, like the Gigabyte I did yesterday, or not yesterday, but the last video I did with the Gigabyte board, that was like 4 milliohms RDS on. And essentially that means that Gigabyte board for a given amount of current going through the low side MOSFET produces 33% more heat than this MOSFET. So I'm actually like, this actually really, really surprised me when I saw the 4C024s on the Gaming Plus, because I was expecting something around 4 milliohms, and I got something that's around 3. And that's actually that makes a pretty significant difference. So yeah, nice enough MOSFET with the 5 phases and, a ton of MOSFETs in here. This VRM should actually do just fine in terms of thermals, because the Gaming Plus, which had much less substantial, like this heatsink right here, is very big. Like, it's really heavy. Surface area wise, I'm still not impressed, but it doesn't seem to have, like, it seems to straight up be a straight upgrade in terms of mass and surface area over what the Gaming Plus had. So basically, and the Gaming Plus in my thermal testing was hitting like 105-ish degrees Celsius on the back of the board. So I think this board will be one of the first motherboards where it's like, I'm going to do my testing and it's going to be consistently doing under 100 degrees, even for the high voltage testing at 1.4 volts. So I'm pretty excited about that, because this should be straight up more efficient, and it has a bigger heatsink than what they have on the Gaming Plus. So also the VRM is just, well, they could have probably optimized for thermal layout better. Like if they moved, say, this phase right here, if they moved that phase where you have the SoC, but that would have just made the whole layout awkward. Or they could have moved 3 phases up here, but the thing is the SoC, I think the way the socket is laid out is like you have your V-core power plane in sort of this area, and then the SoC one is here. So if you put the SoC here, it's just kind of awkward because you need to like route the power planes over each other, so that's why you normally see the SoC VRM in exactly the same position for all motherboards, except like the Crosshair 7, which shoves it right in between their phases, because that motherboard is no expense spared. So, oh, added power plane complexity? No, like we're just paying for it anyway. But yeah, so decent enough MOSFETs. Heat sinks look strong enough. Let's talk efficiency. So, 12 volts gate drive, because I actually checked how the MOSFETs on this thing are driven, and they are driven off a straight 12 volts, which is a good thing because these MOSFETs are most efficient above 10 volts drive. So 12 volts drive with 300 kilohertz switching frequency. This may be lower than what the motherboard actually runs at. I'm not sure. I've not run it yet. But it's probably at 300 kilohertz. There's also a good chance that since this is an IR35201, and that's a fully digital voltage controller, you can configure LLC, switching frequency, phase current balancing, temperature balancing, you name it. Like, this thing has a crazy amount of options for control. There's a pretty good chance that like MSI will actually give you access to things like the switching frequency, because they do that for some of their higher end boards that I've used in the past, where it's like you can configure the VRM fully if you have a voltage controller that supports those kinds of options. So this might have the same kind of configuration options that you find on like the Asus Prime Pro. So it'll be possible to tweak the switching frequency up and down. I don't think it'll have phase thermal balance, and I'm saying that because these MOSFETs don't integrate temperature probes into them. So, like, the VRM temperature is probably going to be measured by some resistor buried somewhere in the VRM area. I'm not sure where. Probably around this area. So, thermal balance definitely won't be an option. Current balance could be done because the IR35201 that's a thing it has integrated into it. But anyway, so 12 volts drive, 300 kilohertz switching frequency, because I rate all the other boards at that. 1.42 volts, 75 amps. So that would be like a maxed out first gen 6 core, or 75 amps at much lower voltage though. So the thing is, the voltage does actually increase your heat output because it puts more load on the high side MOSFET. But 75 amps is around the current you would see for like stock on different SKUs. So this is around where some stock CPUs would run. 1.42 volts, 75 amps. You're going to be looking at about 8 watts of heat dissipation, which is almost exactly the same amount of heat that the Asus X470 Prime Pro motherboard produces, except this has a hell of a lot bigger heat sinks. So this thing should absolutely destroy the Prime Pro when it comes to thermals. 1.42 volts, 100 amps. We're looking at around 12 watts of heat output, which is still like in line with the Prime Pro and the bigger heat sinks. And then 1.42 volts, 125 amps, you're going to be looking at around 16.5 watts of heat output. And that's, again, in line with what the Asus X470 Prime Pro motherboard does. And this costs around the same amount as that board does, and that's basically why I'm saying this has a very good chance at being my favorite sort of cost-performance motherboard, because it checks a lot of boxes for me. There's no postcode, which is unfortunate. There's no there's no BIOS recovery options, which is unfortunate. But you do have a solid VRM. You have some basic debug features over here and there. Massive heat sinks. And the Gaming Plus already had me very I was relatively impressed with the Gaming Plus's memory overclocking capabilities. And to be completely honest, as weird as the MSI BIOS is, in terms of layout, once you get used to it, I rather like it. In my opinion, it's one of the less obnoxious to use BIOSes. I think most obnoxious BIOS always goes to ASRock. I don't know how they do it. It's like Gigabyte's BIOS, sometimes is awkward to work with, but then ASRock BIOS is just infuriating as far as I'm concerned. So yeah. Anyway, so that's the efficiency and some of my thoughts on why I think this would be a really solid motherboard. Let's go for the SoC VRM. So that is just a straight 2-phase running off of the 3598, same 12 volts drive. And for that VRM, efficiency-wise, 1.2 volts, well, you're looking at basically the same results as the Gaming Plus, because it's basically the same VRM as the Gaming Plus, though they did change what capacitor situation there. Like, the capacitors they're using changed. The Gaming Plus has a SMD capacitor, like a big SMD capacitor sitting on the output, whereas this has a bunch of aluminum polymers instead of the SMD cap, which is probably still an aluminum polymer, just because you can get them in both packages. But yeah, so slight difference in the capacitor selection, but ultimately I don't think that'll make much of a difference to the VRM. And so 1.2 volts, 1.25, and 1.3 volts. So 20 amps, 30 amps. So this would be like your just your CPUs, and then your APUs would be all of the higher ones down here. So that would be like your APUs, 50, 40. There we go. CPU up top. Whoops. For that one. So for 20 amps, you're looking at about 2 watts of heat output. For 30 amps, you're looking at about 3.2 watts of heat output. For 40 amps, you're looking at about 4.7. And for 1.3 volts, 50 amps, you're looking at about 6.5 watts of heat output. This thing, though, has a massive heatsink as well. So, yeah, I think this should have no problem. Also, I've not really done much testing with the APUs for like VRM thermals. So yeah, I might have to look into that. The one thing that I will note is that this is technically just a 2-phase. So even if it doesn't have thermal issues, it might not do that great on voltage regulation, but it really depends. If they do give you the option to crank up the switching frequency and the VRM thermals are good, then what I would do to try maximize iGPU overclocking is just crank the switching frequency way up, because that heatsink should be able to take it. And this really shouldn't be getting that hot. So yeah, I would just crank up the switching frequency. That could potentially make up for the fact that, a lot of the other, like the Prime Pro from Asus uses a 4-phase, well, doubled 2-phase. So it looks like it's an interleaved 4-phase. So it's almost a 4-phase. So the Asus board uses almost a 4-phase. Some of the low-end Gigabyte boards use a 3-phase, significantly less power, like less efficient, but still a 3-phase. So in terms of overclocking, that might, assuming you can keep it cool enough, that could have an advantage. But yeah, like if they give you switching frequency control, this could actually be very, very solid for APU overclocking. So yeah, and efficiency-wise, it's just fine. And the heatsink, again, MSI seems to be like leading on heatsink surface area and definitely weight. Like these heatsinks are so heavy. I cannot overstress how heavy they are. So yeah, it's a nice enough SoC VRM in terms of efficiency. It's nothing spectacular. They're all very similar to each other in this. Now then, VDDR, so memory power is done by this, and it just uses your same 4C29 and 4C024. And again, you have 2 high sides and 2 low sides, so those are your low sides. This time they have 1 inductor, right? Which is like here they have 4 Mosfets, 2 inductors, and here they have 4 Mosfets, 1 inductor. If they wanted to, they could have gotten rid of these inductors and just use a single inductor. Because the thing is, if each of these inductors is good for like 30 amps, and then putting them in parallel gives you like 60 amps total current throughput. But if you just bought one 60 amp inductor and put one 60 amp inductor in there, it would be the same current capability for the VRM. So the only reason why you would want to put like multiple inductors like this is surface area. But the thing is, if the electrical, a good chunk of the current rating for an inductor is its own electrical resistance. So these will actually produce more heat for a given amount of current going through them. So the surface area there kind of gets negated, potentially. And the other reason is, obviously, it looks like a 10-phase. So I'm not a fan of the whole cramming more inductors, because it's basically a trap for unaware consumers and reviewers, because there's a lot of reviewers who will just count inductors and go like, yeah, it's 10-phase. It's totally a 10-phase. But yeah, like They could have just put single, big, large, higher current capability inductors instead, and it would have given you the same thing. Which the memory VRM is a single, like the SoC does that, right? Like single inductors, and those aren't high. They won't be like higher current rating there. It's just the SoC doesn't need that much power per phase. And then for this one right here, it's just, well, it's memory. It needs even less power, so they can get away with just one of them. So yeah, that pretty much covers it in terms of the important VRMs. There's obviously a bunch of like minor VRMs scattered around the board, but I just can't ID them, and they're not really, like, they'd be important for repair purposes, but you don't need to worry about them like blowing up or anything unless they're defective from the factory, because if you're overclocking, you won't really change the amount of load on those. It's mostly the V-core. Like, V-core is the one that gets most significantly impacted by overclocking. So yeah, and unfortunately I can't talk about tell you anything about these capacitors because I can't ID, like I have no idea who makes these at all. And I've actually tried again to like figure out who makes them. No idea. Absolutely no idea. MSI doesn't advertise like if they're Japanese or anything. And there's just so many capacitor manufacturers out there. Like so many. And some of them are like really obscure, and I just can't ID these at all, and I have no idea what they are. They're probably like, they're almost certainly some kind of aluminum, solid polymer capacitor. But like like endurance ratings or anything like that, no idea, because I can't ID them. So yeah, that's it for the video. I think this is, we'll see how this does in testing, but I think this could potentially be a pretty solid motherboard. Also worth noting, this doesn't seem to, like, I can't find I've not noticed a clock gen on this thing, or any clock gen mentioned in the marketing, so there's a good chance this can't do BCLK overclocking, for those of you who are, interested in that, which I plan to do some content on that. I just need to get around to, like, actually doing testing on that, because it's really fiddly. Anyway, that's it for the video. Thanks for watching. Like, share, subscribe, leave a comment or any questions or suggestions down in the comment section below. What else is there? Right, and if you would like to support actually hardcore overclocking... Oh, damn, I forgot to thank the patrons for funding the acquisition of this motherboard. So yeah, big thanks to the patrons for, making the... making it possible for me to buy this board. And yeah, if you'd like to support what I do here with actually hardcore overclocking, I have a Patreon, I have a PayPal, there's t-shirts you can buy, there's a link to all of that down in the description below, and it does help out immensely. So yeah, like the only reason I've covered as many X470 motherboards as I've currently covered is because I've been able to buy them. And the only reason why I can go into so much depth is because I actually have them. And it's also the reason why I get away with crappy photos. It's like, because when I try to find pictures on the internet, I need to be actually able to ID components from the picture. Whereas when I have the board, it's just like, well, the picture just needs to, not be incredibly blurry, because I can ID the board in person. ID stuff in person. So yeah, that's it for the video. Thanks for watching, and goodbye.